Solving combined inequalities. In this lesson, you will learn how to solve conjunctions and disjunctions. A conjunction is when we have the word and. So A is less than X is less than B. In other words, X has to be greater than A, and X is less than B. So any solution has to satisfy both of those inequalities. So we're looking for a number that is between A and B. So X is greater than A and less than B. A disjunction is when we use the word or. X is less than A or X is greater than B. So we're looking for a value that satisfies this or this, but not both necessarily. Solve the conjunction and graph. So we have -2 is less than or equal to -x plus 3 is less than 4. So I like to start by putting a dashed line right down through my inequalities. Then it's just like a regular equation in the sense that we want to get x by itself. So we're going to subtract 3, but we must subtract 3 from every side of the dotted line. So we have -5 is less than or equal to -x, which is less than 1. Now we need to divide everything by -1 in order to get rid of the negative sign. So we're going to divide by -1. When we do that, we must make sure we flip this inequality. Flip the inequality sign. So what we're going to do is we're going to say, okay, -5 divided by -1 gives us +5, but this inequality needs to flip over. So now instead of being less than or equal to, it's going to be greater than or equal to. And then -x divided by -1 is +x. We need to flip our less than sign so it becomes greater than. And then 1 divided by -1 is -1. Now our signs are going backwards, so we're just going to rewrite this. So -1 is less than x, which is less than or equal to 5. So this is the solution to the conjunction. And now we're going to graph. So I'm going to label this as a 0, -1, -2, 1, 2, 3, 4, 5, 6. Now, that's a 2. Sorry, my pen doesn't work very well. All right, so -1 is less than x. There is no equal to line here for the less than, so we're just going to draw a circle, but we're not going to close it in. It's called an open circle because it doesn't have that equal to line. And then on the 5, we do have the equal to, so here we have a closed circle. So we're going to color in the dot. That means that 5 can be a value of x, but -1 cannot be a value of x. And then, so -1 is less than x, so we want the numbers that are greater than -1. And then x is less than or equal to 5, so we want the numbers that are less than. And since it's and, we're looking for everywhere that the graphs intersect. So we want all the numbers that are in between. It has to satisfy both of these situations. It has to be greater than the -1, so -1 has to be less than the x, and the x has to be less than the 5, or equal to. All right, let's take a look at a disjunction. So we're going to solve the disjunction and graph. So we're going to, let's start with blue this time. All right, so we are going to look at both of these equations, or inequalities, and we're going to solve them. So we treat them just like we do equations. So we're going to subtract the 1. We'll just work with the 1 on the left-hand side first. So 2k is less than negative 10. So then we divide by 2. So k is less than negative 5. So there's one of them. Now let's take a look at the other one. So we're going to subtract the 0.5. So we have 0.1k is less than or equal to negative 0.5. We just subtracted that negative or that 0.5 over. Then we're going to divide by 0.1 and we get k is greater than or equal to 5. Okay, so now we have these two inequalities and we need to graph them. So first, I'm going to number my number line. And let's see, 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, and negative 5. So let's graph k is less than 5 first. So we have k is less than 5. So we know we need, or I'm sorry, negative 5. So we need a circle on negative 5, but we're not going to close it in because it does not have that equal to line underneath. And because our variable is on the left-hand side, we can take the direction of that inequality. It's pointing to the left, so we're going to go to the left. That's where we want to shade. So we're shading to the left. Okay? Then, so that's good for the first one. Now we want to look at the second one. Oops. Let me pick up my red pen. There we go. And k is greater than or equal to 5. So we want a closed dot on 5 because it does have that equal to. And then we're going to go, because our variable is on the left, we can go with the direction of the inequality. So it's pointing to the right. So we're shading to the right. So you'll notice for a disjunction, our lines never intersect at all. Remember, an open circle means that there's no equal part of the inequality, and a closed circle means that it can also be equal to.